We're going to talk about systems of inequalities in today's video. First, let's look at the first problem. Y is greater than or equal to 3x minus 1. We start at -1, and we have a slope of 3 because that's in slope-intercept form. So that works out really nice. Then we have y is less than or equal to x, and that goes through the origin with slope 1. So it's also pretty easy and in slope-intercept form. So now our objective is to figure out which region of the graph we want to shade. I will go through using two different methods. Whenever it's in slope-intercept form, it's actually pretty simple. We know that the y values have to be greater than 3x minus 1. So since that graph was in red on my graph, that means that my y values have to be greater than the red line, and my y values have to be less than the blue line. So if I'm looking at some sort of line, the y values are greater if I am above the line, and the y values are less if I am below the line. So if I take a look at this, my y values must be greater than the red line and less than the blue line. So notice greater than the red line and less than the blue line. That would occur in this region. All other regions miss at least one of the criteria. So for example, even though in this region over here, we would be greater than the red line, we would also be greater than the blue line, which means that it doesn't work. Okay, problem 2. If I have y is less than -1/2 x plus 1, less than is not an inclusive thing, so my line has to be dotted. So my y-intercept is 1, and my slope is -1/2. So it will look something like this. And I have a dotted line which indicates that my graph does not count the line. Then I have x is greater than or equal to -1. X being greater than or equal to -1 is a vertical line that goes through x equals -1. So I need y to be less than -1/2 x plus 1. Y being less than -1/2 x plus 1 means that it has to be underneath the red line. So it needs to be underneath the red line. But if x is greater than or equal to 1, that means my x values must be greater than or equal to -1. So that means it would be to the right of the blue line. So I need my graph to be below the red dotted line and to the right of the blue line. That would be in this shaded region down here. So that would be my final answer for number 2. Problem 3 has 3 lines that we have to take into account. X is less than or equal to 2. I'll draw that one pretty quickly because, by the way, this black line got slightly off of the center, but that's the y-axis. So I need x is less than 2. I need x plus y is greater than or equal to 3. I'm probably going to graph this one. I could easily shift this into y is greater than or equal to -x plus 3 and graph it using slope-intercept, but I'm going to choose to graph it using standard form. So that means that 3, 0, and 0, 3 are on the line because I graphed by intercepts. So if I cover up x, substitute in 0 for x, I realize that y equals 3 would be the y-intercept. And likewise, if I cover up y, I realize that x equals 3 is the x-intercept. So 3 comma 0 and 0 comma 3 have to be on the graph of the blue line. And so my graph looks like that. That was a terrible drawing. So I'll try that again. And then I have this one, which I will transform into slope-intercept form. Y is less than 1/2 x plus 2. So if I start at 2, and then I have a slope of 1/2, it's going to look something like this. Now I have to figure out where everything goes. So if I am looking at this, I need it to be to the left of my red line. I need it to be below my green dotted line, and I need it to be above my blue line. So to the left of the red, above the blue, and below the green gives me a very small region of the graph right here. So that ends up being my solution. Problem 4, it looks like we have, I could once again transform into slope-intercept form, but I'm going to try and do something a little bit different to show you one other method to figure out how to solve and plot and figure out where the graph goes, where to shade. And so if I take this one and I find the intercepts, if I cover up y, x equals -2 is an intercept. And if I cover up, um, x, I figure out that y equals 2 is an intercept. So if I do that, then I have a graph that goes as a dotted line through those points. Now, if I take a look at what I'm going to make the blue line, and I solve by intercepts again, I figure out that the y-intercept is -4, and the x-intercept is -3. This one is also a dotted line, so it looks something like this. Now, what I'm going to do is I'm going to do something called critical point testing. So critical point testing, what that does is it takes a point in each of the 4 regions of the graph. So there's a region kind of to the top, a region to the right, a region to the bottom, and a region to the left. I'm going to take a point from each region that is clearly not on any line, and what I'm going to do is I'm going to substitute that point into the graph, or into each of these 2 equations up here, and I'm going to figure out whether that point meets both criteria. If that point meets both criteria, then I have a winner. So first, let's talk about region 1. So in region 1, I have the point -2, 1. If that point works, then every other point in that region is going to make both of these actually work. So I'm going to try 4x plus 3y, and I'm going to see if that is less than or equal to -12. I'm sorry, less than -12. So if I check this, I get -8 plus 3, which is -5. That is not less than -12. That is a no. Since that is a no, this point does not work. So that means region 1 will not get shaded. Region 2, it looks like we're using the point 0, 0. So if I take a look at 4x plus 3y. And we have to decide if that is less than negative 12. Once again, I have 0 is less than negative 12. That is not the case. That's a no. So that means region 2 is not my winner. I could check region or the second line, the second equation, or sorry, the second inequality. But since the first inequality gave me a no in both cases, I don't need to check it. Okay, now we will check region 3. Region 3 appears that we have the point -3, -2 that we're checking. So 4x plus 3y less than negative 12. I have negative 12 minus 6, which is negative 18. And negative 18 is less than negative 12. So that is a yes. Now I'm going to check the other equation. If it works in the other equation, then I have a winner. Negative x plus y is less than, or I'm sorry, greater than 2. If this works, then we have a winner. 3 minus 2 equals 1, which is not greater than 2. So that's a no. So that means region 3 is not my winner. So finally, I'm going to check region 4. If I check region 4, my guess is it's a winner because all 3 other regions have failed so far. So if I'm looking at this, I'm at -4, -1. That's the point that I'm going to check. So if I take 4x plus 3y, is that less than -12? That clearly is because that's -19. And then if I check -x plus y, that equals 3, which is greater than 2. So every point in region 4 is actually going to work. I get a double yes, and a double yes means since I only have 2 inequalities that I'm dealing with, a double yes means that region 4 is the winner, and so I am going to highlight that. That would be my final answer. So that's your first check into critical point testing. I'm going to pause this, and then numbers 5 and 6 are going to pop up on the screen, and we'll talk about them for a minute before the video is over. If we take a look at problem 5, and we graph each of these, I converted the blue one into slope-intercept form. We see that we have parallel lines, and we are supposed to have y be smaller than or less than or equal to the red line and greater than or equal to the blue line, which gives us this green shaded region in the middle of those 2 parallel lines. If we look at problem 6, I graphed each of these 3 lines. I noticed that the 2 that are y is all isolated by itself. Y is less than the red line, greater than the green dotted line. So that means we're really down to 2 regions, just this region 1 and region 2. I checked region 2 because region 2 is a little easier to check because it has a 0 value, so that's really easy to plug in. And then when I check this, I see that -1 greater than -6 works. So that means since this works, it is the only region that I'm going to get that's a correct answer. And I would shade this region right here, and this region would be my final answer.